Hi everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be finding the cube root of a complex number. I say the cube root because we're probably going to end up with the principal cube root of this complex number, because a complex number has 3 cube roots. A real number has only 1 cube root, and all real numbers have a cube root, including 0, negatives, positives, all of them. But in the complex world, things are different. They are very complex. So welcome to the complex world. And if you're new to complex world and the complex numbers, then go ahead and check out my lecture videos. This channel is called aplusbi because aplusbi is a complex number, and we usually denote with z. So we kind of say, okay, suppose z is equal to aplusbi, and then we plug it in, substitute, so on and so forth. A lot of problems can be solved that way, especially equations where z is the unknown. Or when we have z bar, absolute value, all of that stuff you can find in the lecture videos. Anyway, so how do we find the cube root of a complex number, and what is that supposed to mean? It just means that you got to find a complex number whose cube equals this number inside, which is 52 plus 47i. So can we just try some numbers until we get this? Well, that could take forever. In this case, it wouldn't take forever. It would probably take a finite amount of time, but it still would be time consuming and kind of very non-elegant, don't you think? I mean, trial and error is okay once in a while, but in this case, no. We're going to go very technical, very mathematical, okay? So, first of all, let me tell you a couple different things about complex numbers. For example, if you have a complex number z, let's call that z equals a plus bi, you can kind of plot it in the complex plane, which is also called the Argand plane. This is the real axis, this is the imaginary axis, this is like a, this is like bi. Complex number is like a vector, or you can think of it as a point on the coordinate plane, so on and so forth. Every point represents a complex number, right? So when you have a function on a complex number, you can't graph it because it's kind of two-dimensional to two-dimensional. Anyways, that's a different story, but here's what I wanted to say. This complex number makes an angle, the vector of theta. That's called the argument. And of course, the distance from 0 is called the modulus, or the absolute value. So r is the absolute value of z, which is given by the square root of a squared plus b squared. And theta is also given by trigonometric arguments, like, for example, tangent theta would be b over a. Of course, it's not always b over a because, well, never mind. It's always b over a, but arctangent b over a is not always going to give you theta. I think the right way to say that, because this is always true. Make sense? Think about arctangent and you'll hopefully get it. Okay, so why did I say all of that? Because when you cube a complex number, suppose the cube root of 52 plus 47i is equal to a plus bi, then I could easily cube both sides. But what would happen to the argument of the cube of this number? If z has argument of theta, then argument of, if suppose argument of z is theta, then argument of z cubed is just going to be 3 theta from the Moivre's, the theorem, something that I can never pronounce correctly. I know people like, you shouldn't say it that way. I always get it wrong. But I think the spelling is something like this. Let's say the Moivre. Can we kind of like Americanized version? So what does that mean? It means that I can find the tangent, because if you cube this, you're going to get that. And if I look at tangent of this, like tangent 3 theta, the argument would be 3 theta, right? Because of the cube, is 47 over 50. Uh-oh, that gives me a chance to find tangent theta. Yeah, but who would like to solve a cubic equation like this? 3 tangent theta minus tangent cube theta divided by 1 minus, was it the formula? Minus something like this, 3 tangent squared theta equals 47 over 52. And good luck with that cubic equation, right? Of course, we can approach that cubic equation from a different angle. I'm going to show you a slightly different approach, or something that we already came up with. Look at that. Why don't we just cube this and set it equal to that? Because from there, we should be able to find a and b directly, right? Well, hopefully. I don't know. Let's find out. So let's go ahead and cube it. When you cube it, you're going to use the binomial formula or binomial theorem. Let me just, to keep a long story short, I'll give it to you for free, okay? You don't have to pay for it. So now we get something like this. Oops, my b is kind of crooked, so I gotta fix it. And then this would be times I, and we want this to equal what? 52 plus 47i. So this is the cube of a plus bi. Make sense? Just memorize it if you don't want to do it every time. Just kidding. You don't have to memorize it. It's like too complicated. So now this is supposed to be the real part. So that is 52 and that is 47. Make sense? Okay. Where do we go from here? We get a system. Nice. We can go ahead and solve this system, right? Maybe, I don't know. Could be hard, but we can try. And to solve the system, we're probably going to introduce another variable because this system is not homogeneous. So I can't do that, can I? I mean, I was thinking about replacing b with something like a t, okay? BAT formula. But then I'm going to have a number on the right-hand side. I don't think that's going to be helpful. Oh, you know what? I could do it and maybe divide both sides. So here's one way to approach it, I think. I didn't check it. So if you try that, a squared t squared, that should give me a cubed minus 3a cubed t squared. And then if I do that on the second equation, then I would be getting 3a squared times at minus a cubed t cubed. And that should be 3a cubed t minus a cubed t cubed. So we can kind of factor out an a cubed here, 1 minus 3t squared. And here we can kind of take out an a cubed and 3t minus t cubed, right? Something like that. And then divide these. A cubed is going to cancel out, and that should give you 52 over 47. And then from there, you'll get a cubic equation, but it's really no different than this one. Look at that, right? It's kind of like, because b over a is tangent, that's why. By the way, using t, I think, was a good idea, right? I didn't even think about it. Anyways, you get the idea. We're kind of going around in circles. So another approach that I thought about for this type of problem was the following. So after we got these equations or system, stop. A cubed minus, no, we'll be able to calm down. Okay, and then we have this. We could go ahead and add these equations, right? If we add them, we should be getting something like this. Equals 99. Nice. And then we can factor this. I don't know if it's going to be helpful, but this is difference of two cubes. And this is like minus 3ab is a common factor, which gives us b minus a. So I should probably negate this to get an a minus b. So like opposite of a minus b is b minus a and vice versa. So it's going to look like this, right? If you negate both at the same time. And then I can take out an a minus b, and then inside this plus this, a squared plus 4ab plus b squared is going to give me 99. Is this helpful? Maybe a little bit. I could also think about factoring out an a here, like a squared minus 3b squared. I don't think that's going to be super helpful, except you want to isolate b from here and plug it into this, but that's going to cause a lot of complications. So this problem has a lot of complications. I want to show you something because there's kind of like something that will make this a little easier. It takes some computation, but still a little better than solving the system. So here's what it is. If you think about the absolute value of this number, which is the cube, right? You're going to realize this is a plus bi to the third power, right? Okay. You're going to find out that the square root of 52 squared, oops, we can't even write 52. 52 squared plus 47 squared. After you simplify this, you're going to find 17 root 17. Trust me on that because I did the calculations for you. Now, you know what that means? Because we can take out the cube. It allows us, absolute value allows us to do it. And if you cube root both sides, because this is a real number, you're going to get the absolute value of a plus bi as square root of 17. And since you're looking for integer solutions, are you? Probably, maybe. You can kind of guess or make a more educated guess. I would say, suppose z is 4 plus I, because 4 minus I would produce a minus sign. If you plug this in other words, if you cube it, yes, you're going to get this number. So the answer is, by guess and check, right? 4 plus I, you can solve it, but that would take too long. And as you can see, tada, the modulus and the argument, of course, you have to express it as tan inverse. Again, you could use a triple angle, but hey, Gaussian prime factorization. That's cool. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out my other channel, which is, come on, Cyber Math, Cyber with an S. And bye-bye.